6 months, 3 stages, out of 1,000 plus teams across the country, our team was selected among the top 100 teams in the IIT Bombay's e-Yantra's Robotics Competition. As AIDS students, we were excited to explore robotics and work on the completely autonomous system.
The competition began with Stage 1, where we entered a simulation-based robotics environment. Virtual arenas, autonomous navigation, robot movement logic, and Coppelia Sim-based simulations was completely new for us. In Task 1, started understanding how autonomous systems work, where robot makes decisions and move autonomously inside the arena.
In Task 2, we worked on autonomous decision making, navigation control, and system interaction inside the robot. Then in Task 3, we focused on line following simulations, box picking concept, and arena navigation challenge using Coppelia Sim and the boilerplate code provided by the competition. Most of our implementation during Stage 1 happened virtually inside the simulation environment. At one point, we spent hours debugging a problem only to realize a small logic mistake was causing the entire robot to fail.
These tasks together formed Stage 1 of the competition. After completing all the submissions, we eagerly waited for the results. And yes, we got qualified among the top 100 teams across the country for Stage 2. Until then, everything we worked on was virtual. But Stage 2 introduced us to the real hardware through e-Yantra's own PCB, sensors, and robotics components. Soon after that, IIT Bombay provided us with the kit worth ₹15,000 for implementation.
That's where everything shifted from simulations to real hardware. Our project CropDrop Bot was an autonomous agriculture delivery robot which navigates through farm-like paths, identify crop crates, pick them up, and place them at the correct collection zones. We started assembling the robot, interfacing sensors, configuring motors, and programming in STM32. A significant part of our development was carried out in the Idea Lab, whose equipments and facilities greatly supported our project. Seeing the robot move successfully for the first time after all the assembly and coding genuinely felt happy.
To achieve this, we worked on line following, color detection, autonomous path navigation, box pickup and delivery mechanisms using sensors and electromagnet systems. For line following, we went through PID and reinforcement learning approaches, but later we finalized PID for stable navigations. As development progressed, we slowly understood how multiple systems have to work together to make the robot run successfully. One sensor issue, one loose wire, or one wrong turn angle would completely collapse the direction of the robot.
Building the robot was much harder than we expected. One major challenge was line following, where even small sensor variations caused the robot to drift away from its path. Color detection was also another challenge because lighting conditions and calibration affected the crate identification accuracy. We also spent a lot of time adjusting motor angles during turns because even slight turning errors completely changed the robot's moment. Some days the robot worked perfectly. Some days it tested our patience more than our code.
In the end, we didn't make it through the final stage. And yes, that was disappointing. But when we looked back at the journey, we realized how far we had came from casually applying online to build a completely autonomous system. This journey gave us something bigger than the results. It gave us the confidence to learn new technologies, work through failures, and build something completely from the scratch as a team. And even though the competition ended, the learning, experience, and the confidence we gained from this journey will stay with us far beyond this project. We are proud Eshwarites.